In this video, I'm going to discuss the condition states for pre-stressed concrete. And this includes namely pre-stressed box beams is mostly what I'm going to be talking about, but the guide can be used for your AASHTO beams, your pre-stressed eyes, and even your post-tensioned concrete. And pre-stressed concrete, as you know, is different from regularly reinforced concrete. The reinforcement in reinforced concrete is not pre-stressed. Pre-stressing strands. The pre-stressing strands are different steel, and basically you take pre-stressing strands and string them tight, and then cast the concrete around it, and then release the strands, and the whole box, the whole cross section, from bearing to bearing through the whole span is in compression. And so it behaves differently. Therefore, we have different guidance. So this is just a cross section of a pre-stressed box beam with a void. And you notice the blue crosses indicating the pre-stressed strands in the cross section. And these pre-stressing strands are 6 wires wound around one wire. And you can see how they're embedded inside this concrete. And it's very important that we keep these strands protected because they're doing a lot of the heavy lifting. One of the tables within the manual bridge inspection is table 74, and it's the guidance for pre-stressed concrete. And when we start talking about exposed strands, because that's the deficiency that's controlling most of our poor pre-stressed box beams, exposed pre-stressing is not just those that are visible to the naked eye for the inspector. It's including those strands that are not visible, but there's indications that the corrosive process has begun. So exposed pre-stressing includes those that are above a longitudinal crack, and that longitudinal crack would be located in the bottom flange of the box, above a delamination, above a spall with unsound or even saturated concrete, and consideration should also be given to strands neighboring and above a corroded stirrup. So there's 4 ways that you could say that a strand is exposed. I mean, we really mean exposure to chlorides, exposure to the corrosive process. So moving forward, that's what exposed pre-stressing means. And here's our chart. Our normal, condition state chart moving left to right. You've got your good, fair, poor, and severe, and I've bolded condition state 3 because that's where I'm going to begin talking about our defects. And by and large, as with most materials, the condition state 3, if there's distress, condition state 3 is the best place to start for your quantities, and then we'll determine, how it should scatter. Should it scatter to the good? Should it remain in 3, or should it scatter to the severe? So the first one we'll talk about is the exposed strands, and this is pretty common once the moisture starts wicking through and getting into between the adjacent boxes through the shear keys, and the corrosive process can then begin with that chloride. And this image is a photo taken down the keyway on the underside of the pre-stressed box beam bridge, and there's 2 beams here, one on the left, one on the right, and each of these beams have exposed strands. So when we start talking about linear foot, it's the linear foot of the beam. So each linear foot quantity goes into one of the condition states. And if there's exposed strands, plural, you got multiple strands, a good place to start is condition state 3. The guidance in the manual says up to 1/4 of the beam width if you've got exposed strands, and that again, that would be delamination, spall, or even visible strands. If there's more than 1/4, the condition state 4, inspectors are encouraged to put those linear feet into condition state 4, and even if you have 1 linear foot or 400 linear foot in condition state 4, that is a quantity that needs to have a structural review, and that structural review can indicate that there's no impact to capacity. So there is a possibility for that quantity that was put into 4 to move back to 3, and that has to happen before the report is finalized or the report is approved by the reviewer. So the reviewer is responsible for taking that and doing a structural analysis, or giving it to central office or someone else. Here's a case in point, nice new wearing surface on top, 3-span adjacent pre-stressed box beam bridge. And as we look underside, there's a different story on the underside. You can see we have some pre-stressed box beams with exposed strands. And anytime you see exposed strands, a good place to start is condition state 3. They're by and large going to stay in condition state 3. So here's some other locations of exposed. And even if we see them hanging down, like in this example, if they're visible, we treat them all as exposed, as not doing the heavy lifting. That was span 2, the middle span. This is span 1. Span 1 had the worst or more exposure, and you can see that there's a lot of exposure. And the red box here is indicating that these are portions with more than a quarter of the cross section of the linear foot. The linear foot moving along the beam line would be placed in condition state 4. Here's portions that would be that would probably remain in condition state 3. And again, there could be one linear foot in condition state 4. That means there's going to be a structural review or analysis. So, and it just so happens this structure was closed shortly after this inspection. So moving along to the second defect is efflorescence, and efflorescence we typically see spilling through the keyway where the moisture is active. And if you see rust staining anywhere in the pre-stressed beam, rust staining will go to condition state 3. So rust staining certainly, and if you have built up of efflorescence, condition state 3 as well. Active moisture, this with the rust staining, this would be condition state 3, and if it continues to be active, we would see this progress pretty aggressively. Within the next 3 to 5 years, we'd see those strands open up significantly. Light efflorescence would be state 2, and something light would be, there's evidence that it's there. There's no buildup of efflorescence, but there is evidence of moisture between the keyway. And you're going to discount both beams. So the linear foot is times 2, so to speak. So the linear foot of the beam on the left is condition state 2, and the linear feet the beam on the right is condition state 2 for these adjacent box beams, both. So here's the same example with the active leakage, and 3 years later you could see the strand exposure, and within 3 years there was an impact to capacity. We had to post this bridge. Because we inspect every year, we were able to monitor it, and it wasn't a safety concern, but nonetheless this is showing you that these the corrosive process can escalate once those keyways are open. Cracking, well, we tolerate less cracking for pre-stressed concrete. You can see the dimensions pretty small. Cracking wider than 0.009 inches is going to go into condition state 3. And not the only, but certainly one of the best ways to objectively track cracking, whether it's growing or not through the seasons, is a crack gauge that you can adhere to either side of the crack and watch as it moves two-dimensionally. Cracking can be state 2, and thinking of, you can only see the web face of the exterior beams, but shear cracking or cracking, structural cracking less than 0.009 would be state 2, and then state 1 there could also be cracking in state 1. Now if you have, depending on its location and whether or not that crack is working, so it could be flexure or actively shearing or even some sort of torsion or racking or something like that, consideration should be made for condition state 4, and then again analysis could prove otherwise within that 90-day period. Movement is a significant deficiency. We often see the independent movement between beams where the shear keys fail, and analysis can prove if there's significant movement, if there's active movement. Say this inspector stays underneath the bridge for truck traffic and they're able to measure sort of active consideration for state 4 for that quantity, and again, an analysis could prove otherwise. So here's evidence of movement. This evidence of movement would be placed into the beam girder linear foot, and this would be evidence of movement. Obviously, you got the shear keys. Above the shear keys, cracked longitudinally, full length of the structure, and there's independent beam movement happening here. And by and large, the movement's going to be an indicator of a poor superstructure underneath for these types of superstructures. So the top side, you would see your wearing surface would be rated low because of that longitudinal crack, and that wearing surface would be a square footage. So each square foot would have its condition state. And on the underside, the beams girders for this pre-stressed would be a linear foot. So a linear foot of exposed strands would be it looks like the controlling deficiency here. And while we stay on this topic of top versus bottom, the field report has an item for floor and slab and beams and girders. So there's a deck item, a structural deck item that we rate, and a structural superstructure item that we rate. What I've talked about here is the beams, girders, the linear foot. So each linear foot gets its condition state. And historically, what we've always asked inspectors to do is on the BRD6 is to rate item 1 and 10 the same, rate item the floor and the beams, girder, slab the same. You'll notice that the units are now different because element level is forcing these units to separate, and the slab is a square footage and the beams, girders is a linear foot. So what we're asking inspectors to do is to rate these adjacent pre-stressed box beams for linear foot and square foot. So you'll see a difference, and it won't be significant. And what you will notice by doing that the transition rating, that bold box on the far right hand side within these red boxes, that bold box will be they'll be similar. When you do condition rating inspections, now that's not the purpose of this video, but when you do condition rating inspections, you'll still leave that floor slab and the beams girders the same rating. So if you give it a 1, you would give the beams girders a 1. If you give the floor slab a 2, you give the beams girders a 2. So we're going to still keep that policy, but there's going to be a little bit of a separation when we have two different units here.